You know when you ask your AI assistant a really tough question and you just have to sit there and wait while it thinks? Well, today we're going to pull back the curtain on what's actually happening behind that little animation. We are going to demystify how these large language models actually learned how to reason.
Oh, you've definitely seen this, right? You ask something complex and the chatbot just pauses for a second before giving you an answer. Turns out that's not just for show. It's actually a little window into a huge shift in how these models work. It's a move from just, knowing things to actually figuring them out. So, to really get why this thinking is such a big deal, we first have to look at what these models were like before. They had this fundamental limitation, which we can basically call a reasoning gap. So, your standard kind of vanilla LLMs, they're incredibly powerful. They're trained on just enormous amounts of text with a really simple goal: predict the next word. And that makes them amazing pattern matchers. They're brilliant at understanding language, generating creative stuff like poems, or even spotting bugs in code. But here's the catch, and it's a big one. Because they're just trained to predict the next plausible word, they're built to spit out a direct answer. They are not designed to, work through a problem that needs multiple logical steps. If you ask them something that requires a bit of thought, they can kind of get lost. And here's what that looks like in action. On the left, you've got a simple retrieval question. It's a fact the model can just pull from its memory. Easy. But on the right, that's a reasoning question. I mean, it's super simple for us, but for an AI, it requires a whole process. Figure out the current year, find the birth year, and then do the subtraction. And that's exactly the gap these vanilla LLMs really struggled to cross. So, how did researchers manage to bridge this gap? Well, the solution was actually surprisingly intuitive. They basically taught the AI to think a little more like we do, and to show its work. This whole idea is called chain of thought, or COT for short. And instead of just jumping straight to the final answer, the model is prompted to first generate all the little steps in between. It breaks down a really hard problem into a series of easier, bite-sized ones that it can solve with its pattern matching skills. Just look at the difference this makes. The old school LLM just gives you the number, 5. But the reasoning LLM, using chain of thought, lays out its logic first. It creates a clear path to the answer. And this doesn't just make the process more reliable, it actually lets it tackle way, way more complex problems. And boom, that brings us right back to the beginning. That little thinking animation you see, that's the user interface telling you that, behind the scenes, the model is busy generating its own chain of thought. It is literally taking a moment to work through the problem. Okay, so we get the what. We want the model to show its work. But the how? How do you actually train an AI to think this way at scale? This is where things get really clever. All right, the first thing you'd probably think of is what's called supervised fine-tuning. You'd get a huge data set of problems, you'd pay a whole bunch of people to write out these perfect, step-by-step solutions, and then you train the model on those examples. The problem? It is incredibly expensive, it takes forever, and as it turns out, it might not even be the best way to teach an AI. And this right here is the crucial insight. Forcing a model to follow a human's reasoning path, it's kind of like forcing a fish to climb a tree. It's just not natural for it. An AI could find a totally different, maybe even more efficient, or completely non-human path to get to the right answer. So how do you teach it to find its own way? The answer? Reinforcement learning. Instead of showing it the perfect answer every time, you just let the model try to solve problems on its own. And whenever it gets the right answer, you give it a little reward. This works beautifully for tasks like coding and math, where you have a verifiable reward. You don't need a human to check the work. You can just run the code or check the final number. It's automatic. Now, traditional reinforcement learning can be, well, a bit of a beast. To make it work for these absolutely massive models, researchers came up with a specialized and much simpler algorithm to get the job done. See, the older way of doing this, something called PPO, it was pretty complex. You actually needed the main LLM to generate the answers, and a second, totally separate AI to act as a judge. The new method, GRPO, very cleverly gets rid of that second model completely. This is where GRPO, or Group Relative Policy Optimization, comes in, and the idea is just so elegant and simple. For any single problem, the model generates a whole group of different possible answers. Then, to learn, it simply compares how successful each answer was to the average success of the whole group. It basically grades its own work on a curve, no external judge needed. Okay, great. So now we have models that can reason.
Problem solved, right? Well, not quite. This actually creates a whole new challenge. We don't just want them to be smart, we also need them to be efficient. And trust me, there's a very real world, practical reason for this. Whether you're a user or a company running these models, every single word or token in that reasoning chain costs money and it costs computer power. Longer thoughts are just flat out more expensive. As researchers were training these models, they noticed something kind of weird. The model's performance, its accuracy, would get better and better, and then it would just hit a plateau. But even after it stopped getting any smarter, the length of its reasoning chains just kept growing and growing and growing.
So why was this happening? Well, it turns out it was a tiny, subtle flaw in the math of the algorithm. It was accidentally designed in a way that punished a short, incorrect answer much more harshly than a long, rambling, incorrect answer. So the AI learned this unintended lesson. When in doubt, just keep talking. It was basically incentivized to ramble.
Okay, we have covered a ton of ground here, from the limits of early AI all the way to the clever algorithms that finally taught them how to think. So, what are the crucial points you should remember from all this? First off, the huge breakthrough was chain of thought, teaching these models to show their work. Second, we got there not by hand-holding them, but with reinforcement learning on things like math and code where answers can be checked automatically. Next, modern algorithms like GRPO are making this whole training process way simpler and more effective. And finally, the next big challenge is efficiency, making these powerful thinkers also concise and affordable.
And all of this leaves us with one last kind of mind-bending thought to chew on. We started by teaching AI to reason a bit more like us, but as we've seen, its way of reasoning might be totally different. So what happens when its methods become not just different, but actually superior? What happens when it creates logical pathways that are so complex or so alien that we can't even follow its train of thought anymore, even when we know it's getting the right answer? That's the question we're all going to be grappling with in the years ahead. Thanks for watching.